Hello, this is just a quick video about OpenFL, and I'm just going to go over some scripts that I've written and describe how you can use OpenFL to control the Form1 or Form1 Plus printer from Formlabs. So the script that we're going to look at as an example today is a vertical peel. So on the Form1 and Form1 Plus, the vat normally will tilt down in between each layer, and that peels off the resin before it lifts up and goes to the next layer. And what we've done is we've written a script that changes the peel action so that the vat does not tilt at all. Rather, the build platform will lift slowly 5 millimeters in between each layer and then return. We'll just take a look at how that script is run, what's inside of it, and what it does. So first off, let's just take a look at a video of that script actually running, and you'll be able to see the first few layers here. Before we move on, I don't want to let it run too long, but what you're going to see happen here is that you're going to do your normal homing sequence. So the vat's still going to tilt on this first layer. It's going to reset, and then it's going to do its 10 lines on the first layer, or 10 passes rather on the first layer, and then it's going to peel vertically, and then it's going to just do each layer, and it's going to pull up 5 millimeters in between each layer. Let's take a look at my computer that's running OpenFL, and we'll take a look at how you can run scripts like that. So the prerequisites are that you need to have Python installed. 2.7 seems to be the way to go. I tried running 3.8 and it didn't really work very well. These are older libraries, so you're probably going to be wanting to run 2.7, some flavor of 2.7. What I've got here is we're looking at a Ubuntu virtual machine that's running on Windows. So if I minimize this, you'll see there's a Windows host here, and I'm using VMware Workstation. I tried a couple other virtualization platforms, and this one seemed to work the best as far as USB speed and reliability, so that's the one that I went with. And this Windows machine is running Preform, the OpenFL version of Preform. The Ubuntu virtual machine is running Python, and it has the OpenFL scripts that I've written. I've got a few of them in here. I've got one that deletes all the blocks. Blocks are the same thing as layers, so each block is one layer of the print job. This is the one that does the vertical peel that we just saw the video of. I've got another one that just changes the Z offset. You can find all of these in the open source manufacturing GitHub. I'll give you the link to that. It's really easy. It's openfl.dev. This has all of the commands that you're going to need to run in order to add vertical peel. Very briefly, what it does is it initializes, which is resetting the printer and homing it. Then it runs through a while loop here, which is going to ask you to set the Z offset. You can either give it an integer or a float, and it will take that and change your Z offset for the print job that's on the printer, or you can just hit enter and skip all of it. Then the next section here is just finding out how many blocks are on the printer, and that's a key thing there. This will run on every block on the printer, and Preform does not overwrite or does not delete previous print jobs. It just overwrites over the top of them. So if your last print had 500 layers and your current print has 200 layers, it's just going to overwrite the first 200 layers of that print, and this script is going to run on 500 layers. So that's why there's the delete blocks script that you can run. It'll save you some time because these scripts do not run very fast. And then the next thing that's going to happen here is it's going to go through a loop that is going to create 2 new lines of code in each block, and it's going to also modify one of them. And these are Z feed rates and movements, and that's how you get your vertical peel. When it finishes, it's going to tell you it's done, and in between each layer, it's going to tell you that it completed for each layer. Let's go ahead and go back to the virtual machine. If I didn't already mention it, the reason that you're going to want to run a Linux machine in a virtual environment if you're using Windows to run Preform is that the USB drivers for Windows just don't work very well for Python. You're going to want to run that in Linux. If you have a OS X machine, you're probably going to be okay to just install Python and run the scripts from that. But that said, VMware Workstation is free if you're only a non-commercial user, and Lubuntu is free. So if you have a Windows PC, you should be able to run Lubuntu. It's not very heavy. So what we're going to do here is change directories to this folder here. And that's where I have all of the OpenFL libraries and scripts installed right now. All we have to do if we want to run the zlift script, for instance, is we're just going to go Python and the name of the script. It's going to ask for the password since I'm running as sudo. It should initialize and ask us for our Z offset. This is asking for input here. If you give it something that it doesn't want, like a string, so any letter or non-digit character other than a period, it's going to present you with the request again. We can go ahead and just set this to -2.5, for instance. Hit enter. It's going to save that. It's going to overwrite the first block on the printer, which each block is a layer. And then it's going to go through that loop over and over again until it gets through. This particular print has 239 layers. We don't have to sit here and watch it, obviously. You'll be able to tell when it finishes because it'll tell you it's done. And it'll tell you that it completed X number of layers out of X number of layers, so you can be sure that it did all of them. But that's how you can run these scripts. How you can find them is you can go to GitHub. The easiest way to get there is to just go openfl.dev, and that's going to put you right in the open source manufacturing GitHub page and the OpenFL repository. This main page here is going to be all of the stuff that's pulled from the original repository. For OpenFL, it's going to tell you how to install the OpenFL version of Preform. It's going to tell you how to install all of the dependencies for Python. And it's also going to give you an overview of some commands that you can run to manipulate a print that's on the printer. So you can take a look at that. The other thing that's in here is, if you go up to the top, Community Python Scripts, if you open that up, you've got descriptions of the different Python scripts that I've put in there so far. It kind of tells you briefly how to use them. And disclaimer, they're experimental. If they don't work, it's just kind of how it goes. Just make sure you read all the documentation. You should read this presentation from Formlabs. I'll put a link below. It's also in here in the repository somewhere. I put it in there. And also read the main README file here. Just read all of this to make sure you understand what it's doing. It also wouldn't hurt to go in and look at the examples that Formlabs created. You can see their MIDI example, as well as stippling and insert material swaps, and this is another one that they used for creating PCBs using the laser. Actually, that's another thing we can look at. Hopefully the audio goes through, but there's a video in here of the MIDI. So if that sort of thing's your jam, you can do that. Yeah, let's go back to the Python scripts though. The other thing that's in here, apart from these descriptions and how to use them, the other thing that you need to read is look at inside each one of these Python scripts. There are comments on how to use them. So take a look at that as well. Now, the other thing that's in here is FLP block descriptions. And this is what the header, I'll call it the header, the first 40 or 16 or 18 layers, depending on which layer you're on, of the print of each block. This is what it's doing. So this is showing you homing sequences, the VAT tilting back up again, and setting currents and feed rates and everything. All of these are things that you can use if you want to create your own scripts. You can familiarize yourself with what these are and how to run them by looking at other scripts, like the scripts that I've uploaded, the example scripts from Formlabs, and so on and so forth. So that's a good thing to take a look at. Let's go back here. Here are the scripts. Of course, you're going to go ahead and clone this repository onto your desktop and put it somewhere safe, but these are all the scripts as of the current day, which is May something, in the middle of coronavirus season. I don't know what day it is. I don't even know what day of the week it is. But anyway, that's an overview of the OpenFL scripts and how you can use them. One other thing that I should have mentioned is that in the Python scripts here, you can also find a INI file for the vertical lift profile. What this is it's telling you need to take all of this and paste it over the top of your between layer routine in your material file. So let's just hop over and look at that really quick before I finish here. We can take a look at some of my resin profiles that I've been testing as well. Here's a vertical lift version of the stock resin profile that Formlabs gives you. So if you come down here to the between layer routine, you'll notice basically what I've done is everything after the P1. So I've set the early times peel to 1, so it's only going to do this one time. That's for that initial layer 1 homing sequence, and everything else I've made 0. So you could either do that or just copy and paste this entire block from GitHub, which is what we were just looking at, right into your resin profile. You can keep everything else the same. And then if you run the zlift commands or zlift script, it will result in a print that has vertical lift in between each layer for vertical peel rather than tilt peel. If you have any questions, post them in the comments below. I look forward to hearing from you. If you have any questions, just let me know. Thanks.